When historians and engineers document the great bridges of Europe and North America, they almost always focus on what you can actually see. The sweeping arches stretching across wide rivers, the intricate stone railings shaped by centuries of craftsmanship, the visible structures that have carried people, goods, and entire civilizations forward for generations. But there's another side to these bridges, a hidden side, one that rarely gets discussed, one that only reveals itself under very specific conditions. And that story doesn't begin above the water, it begins below it. This all started with something that on the surface seemed completely routine. A series of water management projects were launched across multiple regions. Rivers were partially redirected, water levels were lowered. In some cases, entire sections were temporarily drained. The reasons were practical: irrigation demands, urban expansion, maintenance for hydroelectric systems. But there was also another objective running quietly alongside those efforts: inspection. Engineers wanted to take advantage of the unusually low water levels to examine aging bridge infrastructure. After all, many of these bridges are centuries old, some even older. Lowering the water would expose parts of their foundations that are normally inaccessible. It was supposed to be a rare opportunity to assess structural integrity, to check for erosion, to determine whether reinforcement was needed, nothing more. But the moment water levels dropped below their historical minimums, something unexpected happened. They didn't just expose the usual submerged supports, they exposed something else entirely. Inspection teams began reporting foundations that extended far deeper than anyone had anticipated, not just slightly deeper, dramatically deeper. Structures that went beyond anything recorded in official engineering documents. And at first that didn't make sense, because these bridges had already been studied, documented, measured. Their specifications were supposed to be well understood. But what the teams were now seeing didn't match any of it. These weren't minor discrepancies. These were fundamental contradictions. The deeper they looked, the stranger it became. Support structures appeared at depths no one had ever recorded before. Not 10 or 15 meters below the riverbed, but 40, 50, even 60 meters down. That's far beyond what would be expected for bridges spanning rivers that historically were never even that deep. And it wasn't just the depth, it was the construction itself. The masonry didn't align with known building techniques from the supposed time periods. It didn't resemble medieval engineering. It didn't reflect industrial-era methods either. In fact, it didn't clearly match anything in the accepted construction timeline. It was as if these structures belonged to a completely different context. Now here's where things get even more interesting. None of this made it into official reports. Public statements about the inspections were uneventful, standard, nothing out of the ordinary. The narrative stayed focused on routine maintenance, drought conditions, and infrastructure checks. But internally, a different picture was forming. Within engineering documentation from that period, certain phrases started appearing again and again. Unprecedented foundation depth, anomalous construction, inconsistent with documented bridge specifications. Those aren't casual observations. That's the kind of language engineers use when something doesn't just look unusual, it fundamentally doesn't add up. Still, the official explanations tried to smooth everything out. Measurement errors, sediment buildup creating the illusion of greater depth, misidentified structural additions from past renovations that had simply been forgotten. On paper, it all sounded reasonable enough. Nothing extraordinary, nothing worth drawing attention to. But the inspection footage told a different story. In that footage, you can actually see engineers standing beside these exposed foundations, and what they're standing next to isn't subtle. Massive stone pillars plunging deep into what should have been solid ground. Structures extending far beyond the expected limits of bridge engineering. And carved details, actual decorative features, appearing at depths where no one should ever have seen them. Think about that for a second. Decorative stonework, dozens of meters below the riverbed. Not rough, unfinished stone, not purely functional supports, but carefully crafted details, ornamental carvings, symmetrical designs, architectural flourishes, all placed in locations that, according to every accepted model, should have always been buried. And that raises a very simple question. Why decorate something no one is ever meant to see? At first inspection, teams tried to make sense of it using conventional explanations. Maybe the bridges were constructed during a time when river levels were significantly lower. Maybe there were temporary structures like cofferdams that allowed builders to work at greater depths. Maybe historical records were incomplete and these were just remnants of forgotten modifications. But as more bridges were examined, those explanations started to fall apart. Because the pattern wasn't isolated. It was repeating across different countries, different rivers, different construction periods. And the contradictions kept stacking up. Why were there intricately carved stone features 30 meters below the current riverbed? Why did some foundation stones look like they were designed to be seen from above, not buried in darkness? Why did certain structural elements continue downward with the same level of craftsmanship far beyond any depth that would have been necessary? And perhaps most puzzling of all, why were these foundations so massive? The visible bridges above them, impressive as they are, don't require supports of that scale. Their size, their weight, their span, none of it justifies the sheer magnitude of what lies beneath. Yet across major rivers, the Rhine, the Danube, the Thames, the Mississippi, the Ohio, engineers were seeing the same thing. Foundations that looked like they were built to support something much larger than the bridges that exist today. That realization didn't show up in official reports, but privately among inspection teams it was being acknowledged. These weren't just bridge foundations. They looked more like the upper sections of something far more substantial, something buried, something that extended far deeper than anyone had expected. And while no one was openly using dramatic language, no one was talking about lost civilizations or anything like that, the implication was still unsettling. Because if what they were seeing was real, then it meant one thing. The bridges we see today might not be the complete structures. They might only be the visible remnants of something much older and much larger, hidden beneath the surface. And just as quickly as these discoveries began to surface, they started to disappear again. Water levels rose, projects concluded, access was restricted, and the deeper parts of these structures, just briefly revealed, slipped back out of sight. What remained were fragments, a handful of reports, a few photographs, and quiet accounts from the engineers who were there before everything was submerged again. But even from those fragments, a pattern was beginning to emerge. A pattern that didn't fit neatly into any established narrative. And that's where this story really begins. As the inspection data slowly accumulated, something subtle but significant began to change. At first, the reports were detailed, thorough. Engineers documented measurements, materials, structural conditions, everything you would expect from a large-scale infrastructure assessment. But over time, the tone shifted. Descriptions became shorter. Technical language became less precise. And certain details, especially anything related to extreme depths, started to fade out of the documentation altogether. It wasn't abrupt, it didn't happen overnight. But if you compare early reports to later ones, the difference is hard to ignore. And then there was the footage. Early inspection videos showed full descents along the exposed foundations. Cameras followed divers and equipment deep below the riverbed, capturing the full vertical extent of these structures. But later footage, it stopped short. Angles changed. Depths weren't fully shown. Some recordings seemed to cut off right where things were getting most interesting. It was as if there was an invisible boundary one that the documentation simply didn't cross anymore. And that's when a clearer picture started to form. Because even with limited data, the patterns were too consistent to dismiss. Across multiple continents, across completely different rivers, engineers were encountering the same set of anomalies. Foundations extending far beyond expected depths. Stonework that was far too refined for buried infrastructure. Structural elements that didn't match known construction techniques from their supposed time periods. And perhaps most intriguing of all, a consistent architectural style. Now that might not sound unusual at first, after all architectural styles often spread across regions and eras, but this was different. Because these similarities weren't appearing in the visible parts of the bridges, the parts influenced by known historical trends. They were appearing deep below the surface, in places that should never have been seen, in sections that, according to conventional understanding, were never meant to be exposed at all. And yet those submerged sections shared a kind of coherence. Proportions matched. Carving techniques were similar. Design elements followed the same aesthetic logic. It was as if these structures, despite being separated by thousands of kilometers, were built according to a shared set of principles, a kind of architectural vocabulary that didn't quite belong to any single known era, but also didn't appear random. That alone would have been enough to raise questions. But then there was the ornamentation. Because the deeper inspections went, the more obvious it became that these weren't just functional supports. They were designed carefully, intentionally. Columns weren't just cylindrical, they were shaped with proportional symmetry. Stone surfaces weren't just rough, they were finished, sometimes polished. And decorative elements, cornices, mouldings, even sculpted figures appeared far below any level where they could have served a practical purpose. Some of these details were found 20 meters beneath layers of mud, others at 30, 40, even deeper. And they weren't isolated. They continued downward, maintaining the same level of detail and craftsmanship the entire way. Now think about what that implies. If you were building a bridge foundation today, even with modern technology, you wouldn't invest time and resources into decorating sections that will never be seen. It doesn't make economic sense. It doesn't serve a structural purpose. And historically, construction has always followed that logic. Functional parts are built for strength. Visible parts are where aesthetics come in. But here that distinction didn't seem to exist. Below the riverbed, hidden beneath layers of sediment, these structures were just as refined as the portions above water, which suggests something very unusual. Either the builders intentionally decorated areas they knew would be buried, or those areas weren't originally buried at all. That possibility changed the entire context. Because if those lower sections were once visible if they were built in open air, then the current river levels don't represent the original environment these structures were designed for. And that raises an even bigger question. What was the landscape like when these foundations were constructed? As inspections continued, the anomalies didn't just persist, they escalated. Below the expected base of certain foundations, engineers found something completely unexpected. Continuation. Instead of reaching a clear endpoint, some structures extended even deeper. And these deeper sections didn't look like rough buried extensions. They looked refined. In some cases, there were archways, vaulted spaces, symmetrical chambers, geometric precision that didn't align with temporary construction techniques like cofferdams. Because here's the thing, when engineers build in water, especially historically, they use methods designed for practicality, not perfection. Cofferdams are temporary enclosures. They allow water to be pumped out so construction can happen in a dry space. But they're resource-intensive, complex, and leave behind clear evidence. And more importantly, they're not used to create elaborate decorative underground spaces. They're used to build foundations as efficiently as possible. But what inspection teams were seeing didn't match that at all. These weren't rough utilitarian structures. They were permanent, deliberate, almost architectural in a way that went beyond simple engineering. And that led to one of the most difficult questions of the entire investigation. How are these structures even built? Modern bridge construction in rivers is a massive undertaking. It requires extensive planning, heavy machinery, and detailed documentation. Pumping systems, material logistics, labor coordination. All of it leaves a paper trail. But when researchers went back through historical records, they found nothing. No documentation of cofferdams reaching those depths. No records of large-scale water diversion projects necessary to expose such deep construction zones. No accounts of the massive pumping operations that would have been required. Nothing that even came close. And when engineers analyzed the footage and tried to calculate what it would take to build at those depths using known methods, the numbers didn't work. Not even close. The scale of resources required would have exceeded what was available during the supposed construction periods by orders of magnitude, which led to a very uncomfortable conclusion. These foundations didn't look like they were built underwater. They looked like they were built in open air, and then buried, covered by layers of sediment, submerged as water levels rose. That idea alone would have been enough to spark serious debate. But what made it even more difficult to ignore was something else entirely. The absence of information. Because when researchers looked at official bridge histories, diagrams, blueprints, engineering records, they noticed something strange. Foundation depths were barely mentioned. Some diagrams showed only shallow footings. Others omitted entire sections of submerged structure. And in cases where photographic evidence clearly showed extensive deep foundations, those details simply weren't reflected in the official documentation. It wasn't just incomplete, it was inconsistent. And that kind of inconsistency is hard to explain. Because if these deep foundations really were part of the original construction, why weren't they recorded properly? Why weren't they documented as major engineering achievements? Why weren't they studied, published, and celebrated? Instead, they were quietly archived, minimized, or left out entirely. And then there were the details themselves. The joints between stones precise. The surfaces smooth even after centuries underwater. The alignment consistent, almost too consistent for structures supposedly built under difficult conditions. Everything about them suggested time, care, and control. Not the kind of rushed, constrained work you'd expect from underwater construction, but something closer to leisurely craftsmanship, executed in an environment where builders had full access, visibility, and freedom to refine their work. Which brings us back to the same unsettling possibility. What if these structures weren't originally underwater at all? What if the environment changed after they were built? Because once you consider that, everything else starts to shift. And the deeper you go into this investigation, the harder it becomes to fit these findings into the version of history we've been given. And we're still only scratching the surface. At this point, the investigation had already drifted far beyond anything resembling a routine infrastructure check. What began as a simple assessment of bridge stability had turned into something else entirely. A slow, uneasy realization that the structures beneath these rivers didn't behave the way they were supposed to. And the deeper the inspections went, the more that realization solidified. Because it wasn't just about depth anymore. It was about scale. Engineers initially tried to rationalize what they were seeing. Larger foundations could mean unstable soil conditions. Deeper supports might be necessary in certain geological environments. Over-engineering, especially in older construction, wasn't unheard of. But these explanations only worked up to a point, and that point had already been passed. What they were looking at wasn't just extra support. It was disproportionate. Foundations that extended far beyond what the visible structures required, not by a small margin, but by a factor that simply didn't make sense. Some of these base structures were massive, wide enough to support something far larger than the bridges above them. In certain cases, the footprint of a single foundation could have accommodated something closer to a large building than a river crossing. And that's when a quiet shift started happening among the inspection teams. They stopped asking, why are these foundations so strong? And started asking, what were they originally built to support? Because if the current bridges didn't require that kind of scale, then maybe the current bridges weren't the original structures those foundations belonged to. That idea didn't appear in official reports, but it showed up in conversations, in private notes, in the kinds of observations that don't always make it into finalized documentation. Phrases like excessive base dimensions, infrastructure disproportionate to visible superstructure, foundations exceed functional requirements. Careful wording, technical, neutral on the surface, but underneath there was a clear implication. Something didn't match. And it wasn't just one bridge. It was many. Across different regions, across entirely different river systems, the same pattern kept appearing. From Central Europe to North America. From rivers like the Elbe and the Seine, to the Potomac, to the Mississippi. Inspection teams working independently of each other were encountering the same anomalies. Depths that didn't align with records. Stonework that didn't match known timelines. And foundations that seemed oversized. Not just slightly overbuilt, but built for something else entirely. And when you see that kind of consistency across thousands of kilometers, it stops looking like coincidence. It starts looking like a system. That realization brought with it a much bigger question. What if these bridges weren't isolated construction projects? What if they were part of something larger, something coordinated, something designed according to shared specifications? Because that's what the evidence was beginning to suggest. A network, not necessarily in the modern sense of highways or railways, but a system of crossings aligned in a way that implied planning beyond individual locations. And if that were true, then whoever built them had capabilities that didn't quite align with what we typically associate with the historical periods assigned to these structures. Now, up to this point, most of the focus had been on the structures themselves, their depth, their scale, their design. But as investigations expanded, another layer of evidence began to emerge. And this one didn't come from the structures. It came from the ground around them. Core samples, small cylindrical sections of sediment taken from around the foundations, started revealing something unusual. Because if these bridges had always been in river environments, you would expect to see gradual sediment build up. Layers of mud and silt deposited slowly over time. That's how riverbeds typically form. But that's not what the samples showed. Instead, certain layers appeared compressed, dense, as if they had been deposited rapidly. Not over centuries, but suddenly, almost violently. In some cases, the stratification, the layering of sediment looked disrupted, irregular, as though massive amounts of material had been shifted in a short period of time. And then there were the flow indicators, signs within the sediment that pointed to water movement far more intense than what these rivers currently exhibit. We're talking about volumes and velocities that would require conditions far beyond normal seasonal flooding, conditions that didn't appear in recorded history. But perhaps the most surprising discovery came from something organic. Vegetation remains. Within certain sediment layers deep below the current riverbeds, researchers found preserved root systems, not driftwood, not random plant debris carried by water, but structured root networks, the kind that forms in soil. On land, these weren't plants that had grown in water. They were plants that had grown in terrestrial environments, and yet they were now located at depths that, according to conventional geological models, should have been underwater for thousands of years. That contradiction is difficult to reconcile, because it suggests that at some point in the past those depths were not submerged. They were dry land, and not just in one location, but across multiple sites, across different rivers, across different continents. And the pattern wasn't random. The depth at which these organic layers appeared was surprisingly consistent, as if they had all been buried during the same general event. That idea of a single large-scale event affecting multiple regions wasn't something officially acknowledged. The explanations offered were more conservative. Localized flooding, gradual shifts in river paths, natural sediment redistribution over long periods. But those explanations struggle to account for the consistency, because localized events don't produce uniform patterns across thousands of kilometers, and gradual processes don't typically leave behind signs of rapid deposition, unless something else happened, something faster, something more intense. Now, around the same time these findings were being discussed internally, another change began to occur. Access started to tighten. Inspection zones, especially those with the most unusual findings, were restricted. Photographic documentation became harder to obtain. Certain areas were no longer available for continued study. Officially, the reasoning was straightforward. Security concerns, protecting critical infrastructure, preventing sensitive structural details from being publicly exposed, all valid on the surface. But the pattern of those restrictions raised some eyebrows, because the areas that were closed off first were the same ones that showed the most significant anomalies, the deepest foundations, the most elaborate submerged structures, the sites with the strongest geological contradictions. Those were the ones that became inaccessible. And among the engineers and inspectors who had seen these areas firsthand, questions started to form. Quiet ones, not openly discussed but difficult to ignore. Because if the goal was simply to protect infrastructure, why limit access to the most unusual findings? Why not focus on areas with known structural vulnerabilities? Why restrict the very sites that could offer the most insight into how these bridges were built? Unless the concern wasn't structural, but something else. Something related not to the safety of the bridges, but to the implications of what lay beneath them. Because by now, the pattern was becoming harder to dismiss. These weren't isolated anomalies. They were part of a larger configuration, a network of structures that shared characteristics across vast distances. Depth, scale, design, geological context, all pointing toward the same uncomfortable possibility that what we see today is only part of the story, and whatever lies beneath may belong to a very different chapter of history. One that for a brief moment during those low water levels almost came into view. By the time these patterns became impossible to ignore, something else had already begun to happen. The investigations didn't evolve. They didn't expand. They didn't even reach a clear conclusion. They stopped. Not officially, at least, not in a way that was openly discussed, but functionally, that's exactly what happened. Because if you look at the timeline of these inspections, there's a noticeable shift. Early on, everything moved forward with momentum. Teams were dispatched, data was collected, footage was analyzed, reports were written with clarity and detail. But then gradually that momentum slowed, and then it stalled. And then without any clear resolution, it ended. Water levels began to rise again as drought conditions eased. River systems returned to their normal states. Access points disappeared beneath the surface. The exposed foundations, those massive anomalous structures, were submerged once more, and with them the opportunity to study them directly vanished. Now on paper the explanation was simple. The inspections were complete. Budgets were exhausted. Priorities shifted. Resources were redirected to other infrastructure projects. All reasonable explanations. But when you look closer, something doesn't quite add up. Because the inspections weren't actually complete. Not in the areas that mattered most. The deepest sections, the ones that raised the biggest questions, were the least documented. Measurements were unfinished. Footage was incomplete. Analysis was interrupted. And the engineers who were involved in those final stages noticed something else. The nature of the reporting had changed. Earlier reports were straightforward, technical, transparent. But later ones, they became restricted. Language grew vague. Descriptions became less specific. Entire sections seemed to avoid detail altogether. It was as if the purpose of the reports had shifted from documenting findings to limiting them. And that's where the mystery deepens. Because if the goal of these inspections was simply to assess structural integrity, why stop at the most critical points? Why leave the most unusual, most significant discoveries only partially explored, unless those discoveries were leading somewhere uncomfortable, something that didn't fit within the established framework? Something that raised questions no one was prepared or willing to answer, because by now the evidence wasn't just pointing to deeper foundations. It was pointing to something else entirely. Something beneath the foundations. Multiple internal reports, rare ones that circulated quietly among engineering circles, described a turning point during the deepest inspections. A point where the structures stopped looking like bridge supports. and started looking like something else. Foundations didn't just extend downward, they transitioned into forms that weren't easily explainable. Support columns gave way to larger structural elements. Simple vertical shafts opened into chambers. In some cases, there were enclosed spaces carved, shaped, and integrated directly into the foundation itself. Not cracks, not erosion, but intentional design. Architectural spaces located 40 meters below the riverbed. Think about that. Not just stone blocks stacked for support, but chambers, spaces with defined geometry, precision, symmetry, and no clear functional purpose, at least not one related to holding up a bridge. Even more surprising, some of these structures extended beyond what had been mapped as the foundation boundary. They continued downward, further than expected, into depths that hadn't even been fully explored. And that's where modern limitations started to show. Because even with advanced equipment, there were cases where drilling systems struggled to reach the base of these structures. Not because of technical failure, but because the depth exceeded what had been anticipated. Which raises an obvious question. If these are just bridge foundations, why are they so deep that modern tools have difficulty reaching their limits? And what exactly lies at the bottom? That question was never fully answered. Because before full surveys could be completed, access was cut off, water returned, and the deepest sections, the ones that might have provided the clearest answers, were once again hidden. But here's the detail that makes all of this even more difficult to ignore. The interruption wasn't gradual. It wasn't a slow winding down of operations. It was abrupt. Engineers described scenarios where inspections were actively in progress and then suddenly halted. Measurements that were underway, left unfinished. Footage that had been recorded, archived before analysis. Sites that were accessible one week, restricted the next. And while official explanations pointed to logistics, budget constraints, scheduling conflicts, completed objectives, those explanations don't fully account for the pattern. Because if resources were limited, you would expect teams to prioritize the most important areas, the most structurally significant, the most at risk. But instead, the deepest, most unusual foundations were the ones left unexamined, while more conventional, shallow structures continued to receive attention. That inversion of priority is difficult to explain, unless the issue wasn't structural, but historical. Because consider what these findings were beginning to suggest. If these deep foundations were genuinely part of the original construction, then the accepted timeline of how and when these bridges were built becomes questionable. If the lower sections show signs of open-air construction, ornamentation, precision, architectural design, then they likely weren't built underwater, which means the environment was different at the time of construction. Which means the rivers as we know them today may not have existed in the same form. And if that's true, then we're not just talking about engineering anomalies. We're talking about a shift in the landscape itself, a transformation, one that would have had to occur after these structures were built. Now imagine the implications of that. Imagine that the bridges we see today spanning rivers across Europe and North America are not complete structures, but partial ones. The upper remnants of something much larger, something built when ground levels were higher, before some kind of event altered the terrain, lowered the land, or filled entire valleys with water. Imagine that these bridges weren't originally built over rivers at all, but across dry land, across valleys, across terrain that no longer exists in the same form. And then at some point, everything changed. Water filled those spaces, sediment buried the lower portions, and only the upper sections remained visible. Reinterpreted, redocumented, integrated into a new historical narrative. Now that idea might sound extreme, but when you look at the combination of evidence, the depth, the ornamentation, the scale, the geological anomalies, it starts to feel less like speculation, and more like a possibility that hasn't been fully explored. Because if even part of this is accurate, then the story of these bridges isn't just incomplete. It's fundamentally different from what we've been told. And that brings us to a critical turning point in this investigation. Because once you start questioning the foundations, you inevitably start questioning everything built on top of them, not just physically, but historically. And perhaps that's exactly why those deepest sections were never fully examined, because sometimes what lies beneath doesn't just support the structure above. Sometimes it challenges it. After the water returned and the inspection site slipped back beneath the surface, you might expect the investigation to continue in another form. More analysis, more publications, more discussion. But that's not what happened. Instead, what followed was something much quieter. The conversation faded, not completely but noticeably. The engineering reports that did surface were restrained, focused on safe conventional conclusions, structural integrity confirmed, minor reinforcements recommended, nothing that would raise eyebrows. And yet behind that calm surface, fragments of a very different story remained. Because even though access to the sites had been cut off, the data that had already been gathered didn't just disappear. It lingered in internal archives, in private notes, in the memories of the engineers who had seen things firsthand, things that didn't quite fit. And when those fragments are pieced together, a clearer picture begins to form, one that's difficult to reconcile with the official narrative. Let's start with one of the most persistent details, the ornamentation. Across multiple bridges in completely different regions, inspection teams reported the same phenomenon. Decorative stonework, deep below the riverbed, not occasional, not accidental, but consistent. Cornices appearing 30 or 40 meters down. Carved figures embedded beneath layers of sediment. Stone surfaces shaped with the same aesthetic care as the visible portions above water. And this wasn't degraded or eroded detail either. In many cases, the craftsmanship had been preserved remarkably well. Sharp edges, symmetrical patterns, design continuity, as if the structures hadn't always been submerged. Because over long periods underwater, especially in river environments, you expect wear, erosion, damage from sediment flow. But these features, these deeply buried decorative elements, often retained a level of clarity that suggested they hadn't spent their entire existence beneath water, which circles back to the same question. Why decorate what will never be seen? And more importantly, were these sections ever meant to be hidden at all? Now, if this were an isolated case, one bridge, one anomaly, you might dismiss it. A unique design choice, an unusual construction method. But that's not what the evidence shows, because this pattern repeats across different rivers, different countries, different supposed construction periods, and yet the underlying design logic remains strangely consistent. That kind of consistency suggests intention, not coincidence. And then there's the matter of craftsmanship. The deeper sections of these foundations don't just display decoration, they display precision. Stone blocks fitted together with minimal gaps, joints aligned with accuracy that rivals modern techniques, surfaces finished in a way that suggests time and control, not urgency. Now think about the conditions under which these structures were supposedly built. Underwater environments, limited visibility, constrained working spaces, constant pressure from surrounding water. Even with today's technology, building in those conditions is complex, difficult, expensive. And historically it would have been even more so, which is why traditional underwater construction methods focus on practicality. You build what's necessary. You minimize complexity. You avoid unnecessary detail. But that's not what we're seeing here. Instead, we're seeing something that looks like it was built in ideal conditions. Dry conditions, open air conditions, where builders could take their time, where precision wasn't compromised, where decoration wasn't an afterthought, but part of the design from the very beginning. And that brings us to another recurring feature, architectural elements. Not just pillars or supports, but shapes and spaces that resemble parts of buildings. Some foundations include archways, others contain chamber-like voids. In certain cases, there are indications of internal passages, spaces that don't serve a clear structural purpose. Now, in standard bridge engineering, you don't include features like that. They add complexity. They don't contribute directly to load-bearing capacity. And they're especially impractical in submerged environments. So why are they there? What purpose did they originally serve? Because whatever that purpose was, it doesn't align with the idea of a simple bridge foundation. It suggests something more elaborate. Something designed with a different function in mind. And when you combine that with the scale of these structures, the picture becomes even more unusual, because these foundations aren't just deep, they're massive, overbuilt to a degree that goes beyond safety margins. Some base sections are wide enough to support structures far larger than the bridges above them. Others extend downward with a consistency that suggests continuation, not just reinforcement. Engineers who examined these features described them in careful, measured terms: disproportionate infrastructure, excessive foundational capacity, structural scale exceeds visible requirements. Again, neutral language, but the implication is clear. These structures don't match what they're supposedly supporting, which raises a simple but profound question. What were they originally built for? Because if the answer isn't the bridges we see today, then we're looking at remnants, partial structures. The visible top of something much larger that no longer exists in its original form. And that idea gains even more weight when you consider the geographic distribution of these findings. Because this isn't limited to one region. It's not confined to a single river system. It appears across a wide network, from Western Europe to Eastern Europe, from North America's eastern rivers to its central waterways. And despite differences in location, culture, and recorded history, the underlying patterns remain: depth, ornamentation, scale, construction style, all aligning in ways that suggest a shared origin, or at least a shared set of principles. And that leads to a possibility that's difficult to ignore. What if these weren't independent construction projects? What if they were part of a coordinated system, a network of structures built according to a unified design logic? Not necessarily all at the same time, but within a framework that remained consistent across regions, because that would explain the similarities. The coherence. The sense that these structures, despite their separation, belong to the same architectural language. And if that's the case, then we're not just looking at isolated anomalies. We're looking at fragments of a much larger picture, a system that once existed across landscapes that may have looked very different from what we see today. Landscapes that may not have included the rivers we now take for granted. Landscapes that at some point changed, rapidly enough to bury massive structures, thoroughly enough to redefine entire regions, and subtly enough that over time the original context was forgotten, replaced by a new interpretation. One where these structures are simply bridge foundations, even if everything about them suggests otherwise. And the deeper you go into this, the harder it becomes to accept that explanation at face value, because when structures this consistent, this deliberate, and this unusual appear across such vast distances, it stops looking like coincidence, and starts looking like something we haven't fully understood yet, something that was briefly revealed, and then quietly hidden again beneath the water. By now, the structural anomalies alone were enough to raise serious questions. But it wasn't just the structures, it was the ground around them. Because when researchers began analyzing sediment layers and core samples taken from these sites, they uncovered something that may be even more difficult to explain than the foundations themselves. At first glance, river sediment follows a predictable pattern. Over time, layers build up gradually. Fine particles settle, organic material accumulates. The process is slow, consistent, and relatively uniform. But the samples taken from around these deep foundations didn't follow that pattern. Instead, they showed signs of disruption. Certain layers were compressed in ways that suggested rapid deposition, not the slow accumulation you would expect in a stable river environment. Some layers appeared almost chaotic, as if large volumes of material had been moved and settled in a short period of time. And in between those layers, there were gaps, irregular transitions that didn't align with gradual geological processes. It looked less like steady sedimentation, and more like interruption. Now that alone might still fall within the range of natural variation. Flooding events can deposit large amounts of material quickly. Rivers can change course. Environments can shift. But then came the flow indicators. Within these sediment layers, researchers identified patterns consistent with extremely high-energy water movement. Not typical river flow. Not seasonal flooding, but something far more intense. Something capable of transporting large volumes of sediment rapidly. Something that would require water movement on a scale not reflected in recorded history for these regions. And that's where things start to become harder to explain using conventional models. Because while extreme events do happen, they usually leave clear, well-documented evidence. Historical records, geological markers, widespread acknowledgement. But in this case, the evidence was localized to specific depths, consistent depths across multiple sites, which suggests something more coordinated, something that affected multiple regions in a similar way. And then there was the most unexpected discovery of all, vegetation. Deep beneath the current riverbeds within these same sediment layers, researchers found preserved organic material. Root systems, not just fragments but structured networks. The kind that forms when plants grow in soil, on land. These weren't aquatic plants. They weren't debris carried by currents. They were remnants of vegetation that had once been anchored in place, growing in stable terrestrial conditions. And yet they were now located at depths that should have been underwater, according to conventional timelines for a very long time. That contradiction is difficult to overlook, because it suggests that at some point those depths were not submerged, they were dry. And not just temporarily, long enough for plant systems to develop, long enough for soil layers to form, long enough for an entire terrestrial environment to exist. And then something changed, because above those organic layers the sediment tells a different story. Rapid deposition, high-energy water flow, compression, burial, as if the landscape was transformed, covered, submerged, and preserved beneath layers of material that arrive faster than natural processes would typically allow. Now, the official explanations attempt to account for this. Localized flooding, river migration, long-term environmental change. And while those factors do play a role in shaping landscapes, they don't fully explain the consistency, because these findings aren't scattered randomly. They appear at similar depths, across different rivers, across different continents, which raises a very important question. What kind of event could produce that level of uniformity? Because for multiple regions to show the same pattern, buried vegetation disrupted sediment, deep structural submersion, there would need to be a common cause. Something that affected all of them within a similar time frame, not gradually, but decisively. Now, around the same time these geological findings were being reviewed internally, something else began to happen. The investigation didn't expand to include them. It narrowed. Access to certain data sets became restricted. Core sample results weren't widely published. Follow-up studies were limited. And once again, the areas with the most unusual data were the ones that received the least continued attention. Officially, the reasoning remained consistent. Resource allocation, project scope limitations, focus on immediate infrastructure needs. But just like before, the pattern raised questions. Because if these findings were purely geological, why not study them further? Why not integrate them into broader research? Why not use them to refine our understanding of how these river systems evolved, unless those findings didn't just challenge geological assumptions, but historical ones as well? Because when you combine the structural evidence with the geological data, a very specific picture starts to emerge. Not a complete one, but a consistent one. A picture of structures that appear to have been built in open air, on land that is now submerged, surrounded by sediment layers that suggest rapid burial, above organic material that indicates a former terrestrial environment, and repeated across multiple regions. Now, there are only a few ways to interpret that. Either these are highly unusual, isolated coincidences that just happen to align across continents, or they are pieces of a larger event. An event that altered landscapes, raised water levels, deposited massive amounts of sediment, and transformed dry land into river systems. If that sounds like a dramatic shift, that's because it is. And it's not the kind of shift that fits neatly into gradual models of change. It suggests something faster, something more disruptive, something that would have had a significant impact on existing structures, burying them, submerging them, leaving only their upper portions visible. Which brings us back to the bridges. Because if those deep foundations were originally built on dry land, and if the surrounding environment changed after their construction, then what we're seeing today isn't the original context. It's the aftermath. A redefined landscape, where structures that once stood fully exposed are now partially hidden, where foundations that once supported something larger are now interpreted as overbuilt supports, where architectural details that were once visible are now buried beneath layers of sediment and water. And if that interpretation is even partially accurate, then the implications extend far beyond bridge engineering, because it means we're not just looking at unusual construction. We're looking at evidence of environmental change on a scale that isn't fully accounted for in the narratives we rely on. And that might explain something else. Why the investigation didn't continue. Why access was limited. Why the most unusual findings were left unexplored. Because sometimes the challenge isn't collecting data, it's deciding what to do with it. Especially when that data doesn't fit the framework you're working within. Especially when it suggests that the story you've been telling might be missing something important. And in this case, that something might not just be a detail, it might be an entire chapter. One that for a brief moment surfaced during those low water levels, and then quietly slipped back beneath them. By the time the water levels stabilized and the inspection programs were officially wrapped up, something had become increasingly difficult to ignore. The investigations hadn't reached a conclusion. They had reached a limit. Not a technical limit, not a logistical one, but something else, something that felt more like a boundary than an endpoint. Because when you look at how the entire process unfolded, there's a pattern that stands out. The closer the inspections got to the deepest, most unusual structures, the less complete the documentation became. The more restricted the access, the fewer the answers. And that's not how investigations typically work. Normally, the most unusual findings become the focus. They attract more attention, more resources, more analysis. That's where breakthroughs happen. But here, the opposite occurred. The most conventional areas were fully documented. The shallow foundations were measured, recorded, analysed. But the deeper sections, the ones that raised the biggest questions, remained partially explored, and then effectively abandoned. Now, if you step back and look at that pattern objectively, it leads to a very specific line of thinking. Because if those deep foundations were simply unusual engineering, they would have been studied. If they represented a breakthrough in historical construction techniques, they would have been celebrated. If they were evidence of forgotten methods or advanced capabilities, they would have been published, debated, and widely discussed. But none of that happened. Instead, they were minimized, archived, and in some cases omitted, which raises a difficult question. What kind of discovery doesn't get pursued? The answer in many cases is this: the kind that doesn't fit, not just into existing knowledge, but into the broader narrative that knowledge supports, because by now the implications of these findings were becoming harder to contain. Let's connect the dots. We have foundations extending 40 to 60 meters below modern riverbeds. We have decorative elements at depths where they should never have existed if they were built underwater. We have structural precision that suggests open-air construction, not submerged assembly. We have geological evidence indicating that these depths were once dry land. We have sediment layers pointing to rapid, large-scale environmental change. And we have consistency across multiple continents. Now take all of that together, not as isolated observations, but as parts of the same system. What does it suggest? At the very least, it suggests that the current landscape may not reflect the conditions under which these structures were originally built. At most, it suggests that something significant happened after their construction, something that altered the terrain, buried large portions of existing structures, and introduced water into areas that were previously dry. Now that idea leads to a much bigger question. If these bridges were originally built across dry land, then what were they connecting? Because bridges, by definition, connect two sides of something. A river, a valley, a gap. But if the rivers didn't exist in their current form at the time of construction, then these structures may have served a different purpose. They may have been part of a transportation system that operated across land, a network of crossings designed for a landscape that no longer exists. And if that's true, then what we see today, the rivers, the valleys, the terrain, is not the original setting. It's a modified version, an outcome. Now imagine what that implies on a larger scale. Imagine that across Europe and North America there once existed an interconnected system of infrastructure, not necessarily identical to what we have today, but organized, coordinated, built with a shared architectural language. And then at some point, that system was disrupted, partially buried, submerged, reinterpreted. Over time, new structures were added. Older ones were modified, and the original context was gradually replaced by a new narrative, one that fit the visible remains, one that explained the structures as they appear today, not as they may have originally existed. Now, to be clear, this isn't about jumping to conclusions. It's about recognizing patterns, because the evidence doesn't tell us everything, but it does tell us enough to raise questions. And those questions don't go away just because the water returned. In fact, they become more important, because the physical access to those structures, the ability to observe them directly, is no longer available. What we have left are records, fragments, observations that were captured during a brief window of exposure, a window that closed before a full understanding could be reached. And that brings us to one of the most overlooked aspects of this entire situation, the disappearance of documentation. Not in a dramatic sense, not entire archives vanishing overnight, but smaller, more subtle forms of absence. Incomplete datasets, missing segments of footage, reports that reference observations without including supporting detail. It's not enough to draw immediate conclusions, but it's enough to notice, because when multiple independent observations point in the same direction, and the corresponding documentation becomes less accessible, it creates a gap. And that gap invites speculation. Not because speculation is the goal, but because explanation is incomplete. Now there's one final detail that ties all of this together. And it's not about what was found, it's about what wasn't. Because when the water levels returned to normal, there was an opportunity, at least in theory, to continue the investigation using other methods. Advanced scanning, remote sensing, drilling, follow-up studies. But those efforts didn't happen at scale, not in a coordinated way, not in a way that matched the significance of the initial findings. And that absence is telling, because if the goal was to understand these structures fully, you would expect that effort to continue, especially given how unusual the initial discoveries were. But instead, the focus shifted away, and the deeper questions remained unanswered. Which brings us to a point where the investigation as it stands leaves us with something unusual. Not a conclusion, but a configuration. A set of observations that, when viewed together, suggest that there's more beneath these bridges than we currently acknowledge. More depth, more structure, more history, and possibly a different version of events than the one we've accepted. And that leads directly to the final question, not about what was found, but about what remains, hidden, submerged, waiting beneath the surface just out of reach. Because if one brief period of low water revealed this much, what would a full exposure reveal? And more importantly, why haven't we tried to find out? When you step back and look at everything together, the structural anomalies, the geological inconsistencies, the missing documentation, a single realization starts to take shape. This wasn't just an investigation that ended. It was an investigation that stopped right when it became most interesting. Because think about the sequence. Water levels drop. Previously hidden structures are exposed. Engineers begin documenting findings that don't match existing records. The deeper they go, the more unusual those findings become. And then, before the deepest sections can be fully explored, the process is interrupted. Water returns. Access is restricted. Documentation becomes limited. And the entire situation quietly fades from focus. That pattern is hard to ignore, because it suggests that the most important part of the investigation, the part that might have answered the biggest questions, was never completed. And that leaves us in a very specific position. We're not dealing with a solved mystery. We're dealing with an incomplete one. Now at this point, it's worth revisiting the core elements of what was actually observed. Not interpretations, not theories, just the consistent, repeatable findings. Deep foundations far deeper than recorded specifications. Ornamentation carved details located dozens of meters below the riverbed. Scale structures large enough to support something significantly bigger than what exists today. Construction quality, precision, and craftsmanship suggesting open-air building conditions. Geological evidence, sediment layers indicating rapid deposition and organic material pointing to former terrestrial environments. And finally, pattern these features appearing across multiple regions, not as isolated anomalies but as part of a broader configuration. Those are the facts as they were documented during that brief window of exposure. And even without drawing conclusions, those facts raise questions, because they don't align easily with conventional explanations. They don't fit neatly into the timelines we've been given. And they don't behave like typical examples of historical bridge construction. Instead, they point to something more complex, something layered, something that may involve more than one phase of development. Because one way to interpret all of this, perhaps the simplest way, is this. What we see today is not the original structure. It's a modified version, an upper section, a reconstruction built on top of something older. That would explain the mismatch in scale, the difference in construction style, the presence of deeper architectural elements that don't serve the current structure. It would also explain why the foundations seem overbuilt, because they weren't originally designed for what's there now. They were designed for something else, something larger, something that no longer exists in its original form. Now combine that with the geological evidence. If those deeper sections were once above ground, and if they are now buried beneath layers of sediment and water, then at some point the environment changed. Not gradually, but significantly enough to alter entire landscapes, to submerge large areas, to bury existing structures, and to leave only the upper portions visible. That kind of change doesn't just affect one location, it affects regions, possibly continents. And if that's the case, then what we're seeing isn't just a series of unusual bridges, it's the remnants of a different landscape, one that existed before the current configuration of rivers and valleys. One that may have supported a network of structures, transportation, architecture, infrastructure that has since been partially erased. Not completely gone, but hidden, integrated into what we now recognize as something else. And that brings us to a perspective that's both simple and unsettling. Because if these bridges are not what we think they are, if they are only the visible portions of something older, then how many other structures might be like this? How many buildings, foundations, or landmarks are partially buried? How many have been reinterpreted based on what's visible without accounting for what lies beneath? And how much of our historical understanding is built on incomplete information? Now, to be clear, this isn't about rejecting everything we know. It's about recognizing that what we know may not be the full picture, because history, like any field of study, is built on available evidence. And when new evidence appears even briefly, it has the potential to reshape that understanding. But only if it's fully explored, only if it's allowed to be examined without limitation. And in this case, that didn't happen. The window opened, the evidence surfaced, and then before it could be fully understood, it disappeared again, submerged beneath returning water, filed away in restricted reports, reduced to fragments, and left without a definitive explanation. Which brings us back to the question that started all of this. Not what was found, but what it means. Because if even part of this interpretation is correct, if these structures were built in a different environment for a different purpose at a different time than we assume, then the implications are significant. Not just for engineering, but for history, for geology, for how we understand the development of entire regions. And perhaps that's why this story hasn't been widely told, because it doesn't offer easy answers. It doesn't fit neatly into existing frameworks. It raises more questions than it resolves. And those questions lead to places that are difficult to define, but they're still there, beneath the surface, waiting. Because if one series of droughts, temporary, limited, incomplete, was enough to reveal structures like this, then what else is out there? What lies beneath other rivers, other cities, other landscapes that we assume we understand? What would we find if water levels dropped further, if entire river systems were drained, if we had the opportunity and the willingness to look deeper? Would we see more of the same patterns, more evidence of buried structures, more indications that the world we see today is built on top of something older, something larger, something that for now remains hidden? That's the question that lingers. Because the bridge inspections weren't just about infrastructure, they were a glimpse. A brief, accidental glimpse into something we weren't necessarily meant to see. A moment where the surface receded and something else, something deeper, became visible. And then just as quickly, it was gone again. Covered, submerged, left behind, not proven, not disproven, just unanswered. And maybe that's the most important part of this entire story. Not the conclusions we can draw, but the questions we're left with. Because sometimes the most revealing discoveries aren't the ones that give us answers. They're the ones that show us how much we still don't know. Thanks for watching.